Finding the next greater element for each value in nums1 looks like it needs a nested scan, but a monotonic stack gives you the answer in linear time. You receive two integer arrays, nums1 and nums2. Every number in nums1 also appears somewhere in nums2. For each number in nums1, you must locate the first element to its right in nums2 that is strictly larger. If no such element exists, the answer is -1. For example, with nums1 equal to 4, 1, 2, and nums2 equal to 1, 3, 4, 2, the results are -1 for 4 because nothing follows it, 3 for 1 because 3 is the first larger value after the one in nums2, and -1 for 2 because nothing larger follows the final 2. The straightforward way is to, for each query in nums1, scan nums2 to find its position, then continue scanning rightward until a larger value appears. That nested search costs n times m, time where n is the length of nums1 and m is the length of nums2, while using only constant extra space. On the maximum input sizes, this quadratic loop becomes far too slow, so we need a smarter single-pass method. The key insight is that we can process nums2 once with a decreasing stack, recording each element's next greater as we go. We declare a HashMap to store the answer for every value in an empty stack. We iterate through nums2. For each number, while the stack is not empty and the current number is greater than the stack's top, we pop the top and set its map entry to the current number because we have just found its next greater. Then we push the current number onto the stack. After the loop finishes, any values left in the stack never saw a larger element, so we pop them all and record -1 in the map. Finally, we build the result array by looking up each element of nums1 in the map. Let's trace the example. Start with empty stack and map. First element of nums2 is 1, stack empty, push 1. Next is 3. 3 is greater than stack top 1, so pop 1 and map 1 to 3, push 3. Next is 4. 4 greater than 3, pop 3 and map 3 to 4, push 4. Next is 2. 2 is not greater than stack top 4, so push 2. End of nums2. Stack now holds 4 then 2 from bottom to top. Pop 2, map 2 to -1. Pop 4, map 4 to -1. Map now contains 1 maps ta3, 3 maps ta4, 4 maps ta-1, 2 maps ta-1. For nums1 4, 1, 2 we read -1, 3, -1, matching the expected output. You'll recognize this pattern when you need the next greater or next smaller element for each item in an array, especially when the queries are a subset of a larger array. Time complexity is n plus m, where n is the length of nums1 and m is the length of nums2. Space complexity is m for the stack and the HashMap. Try the next problem, same pattern. Subscribe for more algorithm deep dives.